Hey guys, Alok this side. I hope all of you guys are doing very well. And today I just want to discuss about the problem, which is roof construction, and it appears in Code Forces round 769. So basically, what the problem statement says, let me give you a quick overview of the problem. Like, there's a headmaster who is decided to create a roof over the football field. Okay, and the roof construction will require n consecutive vertical pillars basically. Okay, and the headmaster wants the height of the pillars to form a permutation p of integers from 0 to n minus 1, where pi is the height of the ith pillar from the left. Okay, so somewhere somehow we know the cost of the pillars is equals to the maximum value of the bitwise XOR of height of all pairs of adjacent pillars. Okay, in other words we can say the cost of construction is equals to max of pi XOR pi plus 1. Okay, so I will give you the clearance in between the question. Okay, find the sequence, find any sequence of pillars height p of length n with the smallest construction cost. So what we have to do, basically we have to minimize the cost of construction. Let's make it more clear with the help of test cases. So we are having the first test case, which is 2, and the output is definitely gonna 0 1, because how many combination, how many pairs we can make with that two size of f2 size array? Not more than 2, which is 1 comma 0, another one is 0 comma 1. Can we make more than that? No. And the cost of the construction for these kind of pillars is not going to vary, because pi or pi plus 1, that elements are same, then it is not going to vary with the change of position. Okay, let's take another test case, which is 3. Okay, so we are having n equals to 3. So how many combinations we can make? As you can see in this section, they have given a clear specification, which is n equals to 3. There are six sequence of pillars height, sorry, pillar heights. So as you can see, there's a combination, different combination with that solution. So in which case we are getting that minimum one? So we are getting that minimum is in this case as well as in this case. So anyone we can return finally. Okay, so I hope you got the understanding of the problem somewhere. If don't, then no worry, I will tell you furthermore. So what they are doing, basically they are just creating or making a pairs of and taking XOR of that, and they are just required or wanting us to make that XOR as minimum as it can be. So the XOR, sorry, the arrangement of the element of the array, we have to make it somewhere like as we can minimize the cost. Okay, let me tell you with that test case, which is 5. Okay, let's, we have given n equals to 5. So what we can do with that? N equals to 5, one of the way that we can create the array somehow like 0 1 2 3 4. Uh, it is having n equals to 5, and this is the array. So let's check what the basically can it be a cost minimization? So it cannot be. Let me tell you why. So can you please tell me what's the XOR of 3 and 4? It is not let's solve it. Okay, so the XOR of 3 and 4 is gonna 1 1 1, which is 7. Okay, so somewhere it is going to modify, or we can say add something in our cost. So how can be it how can it be a cost optimization? Okay, okay, so finally I'm just going to tell you about the intuition, whole intuition of the solution. So let's just I'm just going to tell you what's the basic thing that you would know is that uh, if you are going to taking XOR of the number which is less number of terms or less number of set bits, or we can say at less position of set bits are there, then it is not gonna work, because it will always increase your price, increase your cost. Let me tell you how. In this case, if we are just going to take the XOR of that those things, then what the thing is will happen, 0 or 1 makes 1, and same as it is. But if we are going to take a XOR with that 0 1 1 with 0 1 0, which is 2 and 3, sorry, 3 and 2. Okay, so what will happen in that time? These are the same thing which is same, so they're not making a cause, and that is how it will give you a always shorter result. But in this case, nothing is there for neutralizing this, or we can say uh, removing this digit basically. So in this case it will also create a kind of impact. Got it? So for the remove of that impact of particular thing, what we should do, we should be taking XOR with that same number of bits can be there. Okay, so if you are going to take the XOR with the 4 and 5. Okay, let me give you 101 it's 5, and 110, sorry, 100 is 4. If you are going to take the XOR of these things, then it will definitely gonna reduce your cost, because the impact of this one is removed by impact of this one. Okay, so now you will always having lesser value than this. Okay, I hope you got it. So what we should do, we should be manage the bigger value, or we can say more bit number with that same kind of number. If it cannot be possible, then we should use 0 instead of that. What 0 will do, if you are just going to take the XOR of 7 with 0, then it will not gonna reduce or increase it. Okay, so it will make it as it is. So it is not gonna impactful or gonna increase our cost. Okay, so the best optimization of this problem of the case which is 5 is can be um, like just take all the four digits, or we can say all the bits which are having higher number of bits in first, or we can say which is 5 having we can say, sorry, 5 is not gonna be there, 4, then 0, then 3, 2, and 1. And one more thing, these guys cannot be produced more than this, because it is having the set bit at the third position, and these guys at max can have the set bit at second position. Okay, so what can be the maximum XOR these guys can make? It is not more than 3. How? Let's check it. 1 1, if we are going to XOR with 1 0, it will make 0 1. Okay, if we are going to make the XOR with 0 1, it will create 1 0. So these things are not gonna make their XOR more than 3. But this is the only thing, this is the only number which can increase our cost. So we just make our cost as max only as this number. If there is 5 extra, or we can say let's take it for 6 1. Mhm, sorry, so that can be the maximum of this one, because what these guys are always gonna reduce the cost, but the maximum cost can be there is nothing which is 4. Okay, so 4 can the only one which can be in make effects, make cost increment. Okay, so that is how we just use this 4 with 0. That is how it is not gonna improve or increase the cost. It will make the cost remain as it is. Okay, so that's the basic idea about the solution. So what we have to do basically, we have to arrange the things like that. Whatever the maximum digit maximum cost can be, we have to make the cost with 0, and more than that costs remain, just arrange them left of that, and the less than of that, the cost, make them as the right of the 0. So I hope you can understand this problem intuition. So let's go for that code. So this is the code of the problem. In this code we just generally take input initially, and we did nothing but first of all, in this case we just count what can be the maximum thing, or what can be the maximum bits in that. Okay, after that we just start from the end to this digit particular, and after that we just start from 0, and end at before that digit. Okay, so what we can say, according to this code, if you are going to create the code of 5 and equals to 5, then what the things are going on, like it is taking that maximum can be 4. Okay, it is just taking that maximum can be 4, and our maximum is not gonna more than 4. So what it is doing in that, it's just placing 4, and then he's just placing 4, and then what he's doing, uh, placing 0 after that, and after that 1 2 3. Got it? So that's the output of this solution. Okay, so let's try to submit it in this section. Can it be gonna submit or not? So it is in queue and problem, it is accepted, so we did it. That's it for this video. I hope you guys are having a better idea about the problem and solution as well. Goodbye guys, we'll meet you in next video.